Hello, everyone, and welcome today to our newest installment of our Student Spotlight podcast series. And today it's my pleasure to have with me here, Gioia. Why don't you tell us like a little bit about yourself, what grade you're in, how old you are, like where you're from, these kinds of things.
So I'm from Italy and I'm currently in my last year of high school. And during the summer, I participated in this CCIR research project of optimization and specifically mathematical optimization using mixed integer linear programming. And since I was young, I've always had an interest in mathematics. And recently, I also developed an interest in computer science. Therefore, I was really excited, and I'm still happy now that I got to participate in this course.
That's amazing. And yeah, why don't you tell us like a little bit about how you chose your topic? Had you done something similar before, or was it entirely new to you?
It was actually entirely new to me. I did have an interest in mathematics and also computer science. Therefore, when I saw this research project that combined both mathematics and computer science together, I thought it would be almost like a perfect fit for me. And it was really new, but the professor and also the teacher assistants, they explained everything really well, and therefore even in a few months I got to know the topic quite in detail and in depth. So yeah.
That's really cool. And how did you choose this particular topic amongst all the options available to you?
I've always had also an interest in applications, and as this course is also it talks about the applications of mathematics in society and in everyday life. Therefore, since this course also kind of like the research project can be implemented in many ways in society. For example, like finding the best way to travel from point A to point B using the minimum fuel required. For example, this is an optimization problem, and this course can like help you in finding kind of the answer to this question. And therefore, seeing all these like possible applications, it really interested me.
Yeah, interesting. So kind of that real world bridging between science and
Mhm.
society, that kind of bridge.
Yes.
Interesting. Yeah.
Mhm.
Yeah, so I would love to hear a little bit more about your research project. So what in particular, walk me through it as if I know nothing about it, which I definitely don't. So I'm very interested to hear what you kind of did in your paper.
Yes, so especially after COVID-19, I guess like healthcare became is quite like an important topic. Therefore, I decided to answer specifically the question on like where is the best location to build hospitals based on like location of cities. And the goal of the project was so that patients can go to a hospital with ease without having to travel too long. But at the same time, I wanted to consider the cost of building hospitals because, like, I guess every country has a budget which they have to like respect. Therefore, in my research project, I aimed in finding the optimal location and number of hospitals so that the cost of building the hospitals would be the minimum. But I wanted to also reduce the distance from each, reduce the total distance from each city to hospital, and therefore trying to find like a balance between not building too many hospitals but at the same time not building too less too less hospitals.
And was your focus only in Italy, or was it like, across all of Europe or the whole world, or how did you determine your like parameters?
So actually in my research project I made a general code which would uh, calculate like the location, but based on like some dummy data, and it's
Mm.
not on a specific country. However, I do plan on actually from now like refining my project and using real data inside this like general model which I have, which I also think is another great thing about like this project which I did. So in optimization problems, I could have the possibility to make like a more general model using dummy data or using specific real data. And I had, well, luckily I could actually make a general model. And after, also now I have the opportunity to actually use real data inside of the general model, which I created in my research paper. So,
That's really, really cool. Wow. And this dummy data, as you call it, was that just like randomly generated, or how did you get those numbers
yes.
randomly? Yeah.
Um, randomly data, yeah.
Interesting. And what were your kind of conclusions? How has the code helped you, as you say, apply this to what we should or should not do in society? Like, how did you, reach your conclusions, I guess?
So I actually in this optimization problem, you usually write an objective, like you tell the code, I want to minimize something or I want to maximize something. And then you put some linear constraints which restrain the solution of the problem. And this makes the problem realistic, as in everyday life we have restrictions, which can be budget, it could be time, effort, energy. And by putting in these linear restrictions and this like objective, which you want to minimize or maximize, then the MILP, or this like the solver, solves for the best location of the hospitals, or in my case it was hospitals, but it really could be anything. It could also be like trying to find like create a meal with where you want to have at least some like amount of vitamins, some amount of proteins. It could really be anything. So yes, it's applicable really to anything.
That is so cool. And so what were the restrictions that you had in place for your code? Was it like budget and distance, these kinds of
Uh,
things?
yes, so in my code, I restricted the budget was, yes, I didn't actually restrict the budget because I did something kind of weird, which I tried putting two objectives into one objective. So I tried minimizing the cost and the distance at the same time. And therefore, in my constraints, I actually didn't put the budget, but it put constraints on that uh, only like hospitals which are built can actually serve cities, and that each city has to actually be served by at least a hospital. And in this way, you don't have cities that are very far away from a hospital. And yeah.
Right. Did you take into account hospitals that already exist, or was it as if nothing existed and you're kind of building anew?
I actually already considered in my code possible like city locations, and then those city locations in the end became also, some of them became hospital locations.
I see. That
So
sounds
yes.
very, very complex. That's very cool. Do you hope one day to get your paper published or kind of use your code for, as you say, like societal applications at large?
So I actually talked with my professor, because also the professor and the TA were really like helping me out a lot in this project. And they told me that I actually can also work on my project, like refine it even more after kind of making like the first project. And after refining it, I can actually like ask them if they could like see it. And then I actually do plan on publishing it somewhere if possible in the future, after I refine it even more using real data.
That is very cool. I cannot wait to see it published out there. That's amazing. Would you say that your experience working like with a professor rather than with a teacher and a big, class of high school students, is that quite different to what you're normally used to? Had you done similar research projects before, or was that different academic structure, that educational structure, quite different to what you're used to?
Honestly, it was really different to what I was used to. I think it was the first time if I can say, I received so much attention from the professor. Like they were so, since it was also a small group of like 5 people with the professor and the TAs, they really helped us a lot. And anytime we had a little doubt on anything or we were not sure how to proceed, they would really they would help us. They would like immediately understand what knowledge was kind of missing in us, and then provide us with what we were missing with. And
Yeah.
this really helped me throughout the whole research project. And it is really different from like school teacher interaction, because I guess in the school there are many more students, and so the teachers have to try to like help at each like they don't really have the energy to fully focus on a student. But in this research project, we really, if I can say, had all the attention. So we could really ask many questions and our doubts would get cleared like on the moment and we didn't have to wait or anything. So yeah.
Yeah. I guess I would say in one sense you have a bit more responsibility because it's such a
Hmm.
large project. It's all on you. The research is all up to you to complete. But on the other hand, you also have a lot more attention and one-on-one supervision. So it kind of goes almost hand in hand. So that's, I think
Yes,
it's very, very,
exactly.
very cool. Yeah, and would you say that CCIR has prepared you to undertake similar projects when you do go to university, or, kind of made you feel more at home in this university environment?
I think it actually did because also the how the course was structured. In the first month we had lectures where we would study MILP, and the TA professors would we would solve optimization problems with them during the lecture. So it was really an active learning. And after that, we had our time to kind of think of our research question or research project. And this whole process, I think, will help me also in university as like this process of interacting with the professor and the TA while also solving the question together. Uh, I did, for example, have guidance, like they did help me solve like the problem or the examples, but now I'm able to kind of think more independently by myself thanks to what I learned from them. And I think this will really help me in the future. Like the way of kind of thinking and like going through the problem and how to like read it kind of. So
Yeah, that sounds great. I'm quite interested in how you were saying that you're bridging mathematics with computer science. Because I do think oftentimes they are kind of conflated, I think, but they are also very different specialties where math often, I think for me at least, feels very abstract sometimes, like especially like um the more theoretical integration, differentiation, you never really see it applied to real life. And I do think computer science sometimes is seen more as a realistic kind of, real world application in which people are making codes for Apple or developing software or engineering or these kinds of things. So I'm very interested how you found this bridge between mathematics and computer science in such a almost a very direct way. How you found that kind of conducive to these real world applications and leaving this abstract theoretical world behind. Was that how was that process for you? Was it very interesting, or tell me like a bit about that?
so at first, I also had difficulty in connecting mathematics and computer science. As you said, it's mathematics seems really abstract and computer science seems really technical with the code and everything. And so at the really beginning of the lecture, the professor actually like kind of explain to us how this optimization works using mathematics. So we encountered lots of linear systems, like system of linear equations, how the system of linear equations was used to model, for example, the price, like everything, I guess, in the world has numbers, like price restrictions also, like budget or time. And by using linear constraints, you can actually like model what is like these constraints and like what is happening in the world. Like for example, how also the optimizer like solves the problem is based on linear algebra. And for example, by you could imagine maybe like a graph, and the graph has some constraints, linear constraints, and then you're trying to find this maximum point here, or it could be the minimum point here, and trying to like kind of visualize it with graphs was like a way to like that aided in my bridging of mathematics and this like kind of computer technical case.
Very interesting. Yeah, I guess sometimes people forget that mathematics is actually very much derived from the real world and actually very it's all around us, isn't it, actually? But I think sometimes when it's taught in school, especially, it veers into this realm of abstraction almost sometimes. Um, but yeah, I guess my last question for you today is, um, do you have any, words of wisdom, pieces of advice, tips and tricks for anyone who is about to undertake a similar research project, any of our new students at CCIR? What would you kind of say to them as words of advice, maybe?
Yes, I would say not to give up. So it's kind of cliche, I guess, but it really is like when you're doing your research project, like also I had so many times I stumbled and I knew the goal, what I wanted to do, but the how was quite difficult for me to like understand. But even in these like difficult times, I really encourage communicating with professors and TAs, and really even like even if you don't really have a question in mind that you want to ask them, just expressing your doubt on like I'm not sure how like this will work. The professors will really help you, and then it's kind of scary, but they understand what you don't know, and so they can like really help you get the knowledge you need to then move forward. And so they were really like they guided me so much during my project that it really helped me. So yes, if you have any doubts or anything, really communicating with the TAs and the professor, I think is one of like the most important things to do.
Well, that sounds very great. Thank you so much for speaking with me today. I hope you have a great rest of your day and very, very interesting
Thank you.
project I'm hearing about. It sounds absolutely amazing. Very nice to meet you.
Thank you. Thank you very much. I'm really thankful I could have this opportunity as well.